So as we continue talking about counting principles, one of the things that's useful in probability is the fundamental counting principle. Sometimes it's called the counting rule, but it's a way to figure out the number of outcomes in a probability problem. And basically what you do is you multiply the events together to get the total number of outcomes. So for example, let's say you go into the cafe and you have your choice of 3 entrees, 4 sides, 2 desserts, and 4 drinks. You're going to pick one from every category. So how many different lunches could we have? Well, you do 3 times 4 times 2 times 4, and that's going to give you 96, meaning you could go into the cafe for 96 days and never have the exact same lunch. And I mean, like, you could have pizza, fries, ice cream, and a Coke, or pizza, fries, ice cream, and sweet tea, or pizza, fries, ice cream, and water. Like, when you change one thing, it's a different meal. So that's how you get the 96 different options. The next example says, how many ways can a 5-question true-false quiz be answered? Think about, for every question, how many choices do you have? You have 2. It's either true or false. So on the first question, you have 2 options. On the second question, you have 2 options. You have 2 options for all 5 questions. So when you do 2 times 2 times 2 times 2 times 2, 5 times, because there's 5 questions, you get 32. Meaning there are 32 different ways to answer this quiz. I could have 32 papers that do not have all of the same answers. Now, if I were to say to you and extend this and say, okay, what's the probability that you get a 100? Now, some of you may say, oh, it's 50% because it's true false. That's 50-50. Well, yes. However, there's only one set of answers that will give you 100. That's 1 out of 32. And when you divide that, that's only 3%. You have a 3% chance of getting 100 on a 5-question true-false quiz. So when you kids are always asking for true, false, or multiple choice, think about it. You probably don't want that. The next example says a combination lock consists of Combination lock consists of the numbers 0 through 29 inclusive. What that means is that the 0 and the 29 are included, as well as everything in between. Okay, so maybe think about your locker combination. How many 3-number combinations are possible if no repetition is allowed? Meaning, what if no number is allowed to repeat? So let's say you're allowed to go into the office and pick your own combination. Now, if you counted all the numbers from 0 to 29, there would be a total of 30 numbers. Okay, if you don't believe me, count out 0 through 29. There are 30 numbers. So you go into the office and Ms. Tharp says, okay, you need to pick your combination. Well, for your first number, there are 30 choices. But if you're not allowed to repeat, then you only have 29 choices for your second number, and then 28 choices for your third number. So when you multiply that together, you get 24,360. So there are 24,360 different combinations that can be formed, even if no numbers can repeat. But think about the question if it were to say how many 3-number combinations are possible if repetition is allowed. Now when you go to pick your combination, you have 30 choices for each number because you could repeat the numbers. So when you multiply 30 times 30 times 30, that gives you 27,000. This next question says, okay, so how many 3-number combinations are possible if the first number cannot be 0 through 9, but there are no other restrictions? Now, if the first number cannot be 0 through 9, that's 10 numbers that you cannot have, which means now you only have 20 choices for your first number. But you still have 30 choices for the second and third because there are no other restrictions. And when you multiply that, you still have 18,000 different combinations. Your homework, again, is going to be to click on this link and do the few questions that are there. And as you deal with, as you're thinking about the permutations and combinations and counting principles, understand that a lot of this goes with probability. And if you were in a statistics class, you'd probably have a whole chapter on this stuff and dealing with probability. So just in case you're curious where this might come up again, that is where.